Hey, welcome back to Math with Patrick. Today is June 26th, and we're solving problem number 177 from the Daily Epsilon calendar. And today, we need to find the nim sum of 42, 36, 12, and 24. And before reading this problem, I didn't really know what a nim sum was, and it comes from the game of Nim. I had to look at the Wikipedia page for a bit. It's one of those games where you have different piles of stuff, and the last player to take something loses. You take turns going back and forth. You can only take things out of one pile at a time, but then you can take as many things as you want. So you could kind of just grab a whole pile if you wanted. And players would just take turns grabbing some amount of things from each pile, and they just try not to be the last one standing. So here, maroon player just took a big grab. They took the whole pile there. And now blue player has to strategize and think, okay, what happens if I take, say, both of these? That would then allow the maroon player to take just the one, and then blue would have to take the last one, and so blue would lose. And so blue does not want to take both on either of these piles, but maybe they just want to take the one. Now, the maroon player, they also, know the rules of the game, and they're thinking, okay, if I take this one right here, then blue could take this one right here, and I'm forced to take the last one, so I don't want to take the one. And rather, it'd be much better to just grab these two in this pile and then force the blue player to take this one right here. So that's how the game works. And there's a mathematical strategy you could use if you wanted to, where you can do a nim sum of all the numbers in or how many things there are in each pile. So at the beginning of the game, there was a 3, 4, and a 5. And if you did a nim sum on 3, 4, and 5, you'd get some kind of number as your result. And that number can dictate the winning strategy to you. Now, I don't really know the strategy all too well, but I just kind of wanted to say what the nim sum is coming from before we start talking about what the nim sum is. To find the nim sum of various numbers, first you got to convert them all into binary. And so first let me just write the numbers down here. And then I'll put a little 10 as a subscript here, just to remind us that these are base 10 numbers, as in there's 4 10s and 2 1s. And when you're writing things in binary, instead of asking how many 10s, 100s, or 1000s you have, these are all powers of 10, you would instead have to ask how many 2s, 4s, 8s, so on and so forth do we have in all of these numbers. So I think the largest one that we need to worry about is 32, because the next power of 2 is 64, and that's bigger than all of these numbers. And so let's just count down by our powers of 2. There we go. And then to write these numbers in binary, we just need to ask how many 32s are there? And there's 1. And then you kind of subtract that 32 from the total. So now in my head, I have a 10 that I'm thinking about. So 16 can't fit in there. 8 does. And that means we have 2 left over. And so I can put a 1 right in here. And so the number 42 is the same thing as adding 2, 8, and 32 together. And so the binary representation of 42 is the same as this number. And if I wrote it in binary, I'd probably put a little 2 right here, again, just to remember that that's a base 2 number instead of a base 10 number. All right, writing a 36 in binary, we can fit a 32 in there, and that leaves us with 4. A 12, we could do 8 plus 4. And then the 24 is going to be a 16 plus an 8. Cool. So here are all of my numbers written in binary now. And to take the nim sum, basically we're just going to add up the digits, although we're not going to carry numbers over. So normally when adding in binary, say we took this 4s column right here, I would add the 1 plus 1, and I don't get a 2, because in binary we only have 0s and 1s. And so the next number that I have to use is 10, and I would carry the 1 over into the 8s column. But for whatever reason, just the way that this operation works, the nim sum does not carry numbers over to the next place. And the nim sum is usually represented as a plus sign with a circle around it. So adding up the digits, we get all 0s in our 1s place. We have a 1 in our 2s place. And then we have 2 1s in our 4s place, which normally, again, would create a 10. We'd carry the 1. But since there's no carrying, we're going to put a 0 here. And essentially, when doing a nim sum, if there's an even number of ones, we'll put a 0. And if there's an odd number of ones, we'll put a 1. And there we go. That does it. So this number right here in binary is our answer. And to figure out what this looks like in base 10, all we got to do is add 2, 8, and 16 together. I'm noticing that the 8 and the 2 make it 10, and then 10 plus 16 is 26. So there's the 26 for today. That's our answer. That's today's date. We're all done. So thanks for coming along and solving this with me, and I'll see you tomorrow. Bye.